Okay, so our topic of discussion today is Unit 2.2, Day 2, and we are going to model linear inequalities. So in a similar fashion that we've been dealing with linear functions and modeling linear functions with equations, we're going to do the same thing, but we're just going to kind of add in an inequality there to kind of get an idea of other situations that can happen. So our objective for today is we're going to model real situations with linear equalities and inequalities to solve problems and identify the relative domain, as we call it. So first of all, we have to remember our four inequalities that we use. And so our four inequalities that we're using are the first two, which do not have the or equal to, are your less than or greater than. And we typically read these from left to right. So typically our variable will be on this side. So it would be x is less than a value, x is greater than a value. And so then we can look at the other ones. We have our less than or equal to, because if we imagine that this is the x over here and then this is the x over here, we have less than or equal to, so that line underneath means or equal to, it can also be equal, or x is greater than or equal to something. So, we just have our four inequalities now. Typically, like I said, we read these from left to right, but most typically we're looking at those in terms of less than, greater than, less than or equal to, or greater than or equal to. Now we do have some key indicator words. So if I was going to say at least 6, what that would typically mean is that we would use that x is greater than or equal to 6, meaning that it's at least 6 and it can be 6 as well. So whenever we see at least, we should be thinking of greater than or equal to. No more than something would be x is less than or equal to, let's say, 50. And so if I said we cannot have any more than 50, that means we can have 50 and anything less than that. And so that would be x is less than or equal to if we had no more than. Now maximum and minimum are kind of self-explanatory, where the maximum would be that x is less than a particular number, and the minimum would be that x is greater than a particular minimum or a particular number. Now in this case, what we can actually have happen is that those can also indicate x is less than or equal to a number, or x is greater than or equal to a number, but what we have to look at is this specific situation, because we have to ask ourselves, can we include that number or not? So is this number part of the problem, yes or no? And that will help us tell whether it's equal to or not. Okay, so we're going to kind of go back over, how we can solve inequalities. So we're going to be working with standard form and we're going to be working with slope-intercept form, but we can also include inequalities into that. And so what we're going to do is we're going to solve these kind of basic inequalities just so that we're aware of how we can solve these again. But the idea is that our steps are pretty straightforward. We can substitute any values if necessary. So maybe we need some values that we can plug in that we can simplify our answer. And then we're going to solve this just like we would a normal linear equation. But the only thing that we have to keep in mind is that if we divide both sides by a negative, that doesn't mean that our answer is going to be negative, but if we divide both sides by a negative, we need to flip the symbol. So let's take a look at this one. So the first one is we're going to substitute p equals 4. So 12r plus 9.8 times 4 is less than or equal to 16. So I can simplify that a little bit. 12r plus 39.2 is less than or equal to 16. I can subtract 39.2 from both sides, which gives me 12r is less than or equal to negative 23.2. Then I can divide both sides by 12. And notice that it doesn't matter that my answer is going to be negative. Because I didn't divide both sides by a negative, I don't flip the sign, or I don't flip the symbol. So the idea is that I have to divide both sides by a negative value in order for that to actually change direction. And so this ends up giving me negative 1.93 as a rounded answer. And so the idea behind this is that we just have to be careful when we flip the inequality and when we don't flip the inequality. Just because our answer is negative doesn't mean that we flip it. Okay, so we have another inequality, but this time it's in kind of more of a slope-intercept form, which doesn't really make a difference. So we can substitute the values as necessary. So y is equal to 1250. So we can plug this in. 1250 is less than or equal to 2500 minus 4x, and we need to solve for x. So in order to do that, I would subtract 2500 from both sides, and that gives me negative 1250 is less than or equal to negative 4x. Remember, that subtraction stays with that term. And now in this situation, what I'm going to end up doing is I'm going to end up dividing by 4, or negative 4, in order to solve this inequality. So I take 1250 and I divide it by 4, and it gives me 312.5. And now, since I divided by a negative, I'm going to go ahead and flip that inequality to a greater than or equal to x. Now I'm going to flip this around just so that it faces another direction. So the inequality points at x, so x is less than or equal to 312.5. And so the idea behind this is that whenever we do this, whenever we divide by a negative, that's when we flip the inequality. Now in this case, I just flipped the entire thing, so everything just kind of mirrors itself. But the idea is that when you divide by a negative on both sides, then you flip the inequality. Otherwise, you leave it exactly how it was. But here we have an answer of x is less than or equal to 312.5. And there's just kind of our basic kind of refresh on how we can solve inequalities. And so that kind of brings us to our next point here. The next point that we have is that we need to understand how we graph these inequalities. So first of all, we can graph y is greater than 3x minus 5 in the same way that we graph linear functions. The last video that you did talked about graphing those things, how we can either graph them with the slope and the y-intercept, or we can graph them with our x and y-intercepts. So in this case, we can just assume that this is just like y equals 3x minus 5. So the first thing is that my slope is 3 and my y-intercept is negative 5. And so I have that. So I can go to negative 5, 1, 2, 3, 4, 5. So here's negative 5. And then I can use my slope, which is ends up being 3 over 1. So up 3 over 1, up 3 over 1. And so before I start to do this, I have to decide my line if it's going to be solid or dotted. Now if you remember from Algebra 1, when we were graphing inequalities, you either had an open circle or a closed circle. This is kind of the same idea. This is open. So solid lines will deal with the or equals to. So solid would be less than or equal to or greater than or equal to. And dotted would be less than or greater than. And so in this situation we have a greater than, and so my line is going to be dotted. So when I draw my line through this, this is going to be dotted because I cannot include values that exist on that line. Because we have things either above the graph or below the graph will be acceptable answers to our inequality. Now the other thing that we have to look at is we also have to shade. Now shading above or below comes with either greater than or less than. Shading above the line is greater than or equal to. Below the line is less than or equal to. Since we have a greater than, we're going to shade above. So everything that is above this line is considered a solution. And so that's kind of our refresh in how we graph inequalities, is that we either dot or shade or we have a solid or dotted line, and we shade above the graph or below the graph. Because if I was to use an ordered pair, say this ordered pair right here, that would work for our inequality. And so those are the kind of things that we have to look for when we're graphing inequalities. Alright, so now we have a situation in which we have an inequality that is in standard form. And so we have one of two options. So we can put in slope-intercept, so y equals mx plus b, and I know this is an inequality, but we can still put it in that same form. Or we can use our intercepts. And so we can use our intercepts the same way that we would do this. And I don't want to say that we would ignore the inequality, but we don't necessarily need to worry about the inequality because that's just going to give us our information. But typically our best bet, so that we can figure out whether we're going to have shading above the line or below the line, is to put this in slope-intercept form. So I'm going to go ahead and put this in slope-intercept form. So the first thing is I'm going to add 2x to both sides. So I get negative 3y is greater than or equal to 2x plus 6. Then I'm going to divide both sides by negative 3. And when I divide both sides by -3, I divide everything by -3. So this is y, and since I divided by negative, I'm going to flip my inequality, is -2/3x plus -2. And so that gives me my slope, and that gives me my y-intercept. So my y-intercept is -2, which is right here. And then I'm going to go down 2 over 3. So 1, 2, 1, 2, 3, put another dot. Down 2 over 3, put another dot. And so now what I come across is, again, am I going to have a solid or dotted line? Remember, solid is less than or equal to or greater than or equal to. Dotted is less than or greater than. So in this case, we're going to have a solid line. And so now I can go ahead and I can just go ahead and draw my line through my points. And then now I have to decide whether I'm going to shade above or below. Remember, shading above is for greater than or equal to, and below is less than or equal to. And so my final answer has a less than or equal to, so I'm going to shade everything below this line. And so this is just our basic interpretation of how we graph inequalities. We're either having a dotted or solid line, or shading above or below the graph. Okay, so a couple of things that we need to look at is, before we finish this up, we have to understand the idea that we can use modeling in order to graph or do anything with this. And so there's 4 different ways that we can model a situation. The first way that we can model a situation is by graphing it. Another way that we can model is we can model with a table, so we can generate a table of values. In order to do those things, what it's best to have is an equation. So if we have an equation, we can graph this, and then we can generate a table. But also, too, what's very important is that you can draw a picture of this. So typically, depending on what information that you're given, you pick one of these ways to model, or multiple ways to model, so that you can at least see visually what you're doing, because not always do you need a graph. Sometimes it's just a table of values, but it's very important to at least draw a picture of the certain situation that we're working with so that we can understand our situation. So here, what we want is we have our what we call a relevant domain, and these are the permissible values of x. So again, domain is values of x, which are relevant to the situation. And the relevant, or what we call relative. And the idea behind this is that we only want specific values of x that actually work for our model. Because obviously in certain situations, as other examples that we looked at, time goes on forever. But we don't want time to go on forever. There are only certain situations that we can use. And so we're going to try to choose values of our domain that we can use that are appropriate to our situation. So we're just kind of looking out for those particular things and finding these relative, or this is relative domain. So we're looking for a relative domain for values of x that are relative or relevant to what we're doing. And so that's going to do it for this particular video on modeling and using inequalities.